Hi, everybody. Thanks for joining again our monthly open call from the SCIMMA project. This is, I just give a brief update about a couple of things that are ongoing. This is, we're entering into our second year of the Harnessing Data Revolution award from the NSF. And at this stage, we want to continue to deepen the collaboration across different groups and communities. So these meetings are going to become even more important as we move forward with that process. I think beyond that, I don't want to say anything more today. So Adam, I'm going to let you continue to chair the call as usual.
Okay, thanks very much. So we're going to hear from the NASA TACH collaboration, which I think is a Transient Astrophysics Coordination Hub. I looked this up earlier on and then immediately forgot if I had to say it. And Tom McGlynn will be leading this presentation, and there will be time for questions afterwards. And Tom will tell you how he wants to deal with perhaps questions coming up.
Okay.
During the call.
So has that is the screen being properly shared now?
Yeah, so it's not in that presentation view, but yeah, we can see your slide in the sidebar of slides.
Yeah. Okay. I just switched it into presentation view, so it should be there. Okay. So I confess I was not at the previous meetings we've had with your group. So if I make something say something incredibly ignorant, please feel about your what something that you've already done. Please don't hesitate to break in. What I was originally going to be talking about was primarily the database, but was suggested that we give a few slides, and I was just going to go, a very broad overview of that, but was suggested that we give a brief introduction to TACH generally, and so Judy prepare some slides, which I will be presenting, but hopefully Judy will back me up if I say anything inappropriate. This is a collaboration which started about 1.5 years, 2 years ago, where NASA is funding an expansion of the activities we have at Goddard Space Flight Center, where we've had for many, many years the Gamma Ray Coordination Network, the GCN, which sends out notices about gamma ray bursts from a variety of sources. So lots of people feed data into us, and we then Scott's system would then send out these notices. And then the other area that we're sort of building on is the HESARC database, which is the High Energy Astrophysics Science Archive, our research center. And the HESARC is NASA's primary archive for high energy astrophysics, but also for reasons that are historical, for microwave background astronomy. And we have data from many missions in the historical sense, and it was thought that it would be useful for us to do several things. First, we were going to make sure that we could make this GCN network better. We could make it more reliable. We could handle immediate searches for counterparts. We could make the user interface better, elements like that. We also could tie the GCNs with the data that the HESARC has, so that if you see a burst that will give a location, you can tie it both to the high energy data that the HESARC has and through the virtual observatory to astronomy data throughout, everywhere. And we also wanted to, a third aspect of this was to do a more sophisticated and careful work in doing the joint localizations when we have multiple detecting satellites. I think in particular, Judy was, BurstQ being the first of a whole set of small satellites that will be continuously monitoring the sky, and want to be able to say how do we actually find these things, and very quickly then be able to get our best idea of where things are happening. And of course, with the gravitational wave astronomy, there's obviously a great interest in being able to very quickly follow up. So just going back a slide here, this is the team we have, and it looks like
Tom, sorry, Leo just made a point. Do you know we're still seeing the title slide?
I see. I am not. So you're somehow you're not seeing the slide that I'm seeing. Interesting.
So I think you may have shared the sort of browser window that had the presentation in or whatever, and for some reason it is not showing us the presentation version that you have.
Ah, I see. Okay. Well, that would. Let me stop sharing then, and we'll see what we can do.
Sorry about that.
Well, this is the okay. Okay. So what do you?
Okay.
What,
I now see a full screen slide, and yes, now you're moving through it.
okay. So this is the team we have, and it looks like a big team, but in fact, many of the people here have only a fairly small fraction of time on this. So it's not a it's not a gigantic project. It's a relatively small team, but there are but it does span both the sort of we have astronomers, we have software scientists, we have people in high energy astronomy, and we have a lot of research scientists who are working on the localization technologies. So this is the team we have. Again, this is actually, I was just talking to this slide a few moments ago, but you guys didn't see it, so I'll give you a chance to take a look at it. I'm going to, again, giving a sense of the three different elements of of what's going on in TACH, improving the GCN, trying to tie the idea of transient information with the data we have from historical missions and active missions, and also doing joint localizations as many new satellites begin observing. And so here's a sort of sense of what's going on here. We have these many sources of data which provide inputs to the GCN, which then sends things out to the community. There are already services like AMON, which tie together multiple services and sort of digest them. This is actually kind of where we're seeing the development of a hierarchical network of these sites of both data providers, of data filters, and of data relayers. And then over here we have the ESARC mission data in our other archives. We have this multi-mission transient database, which is what I'll be talking about in its early stages in a bit. And we're including here obviously data that's NASA data, these things in blue, but obviously many of the important sources of transients in the future are non-NASA missions. Obviously LIGO and Virgo are perhaps most interesting, but neutrino detectors like IceCube, and of course in terms of data volumes, probably the biggest creators of transients are the Zwicky Transient Facility, and soon to be I'm trying to the LSST has been renamed in the name of our Rubin Observatory will be, of course, sending tens of millions of transients every day. So this is our hope in the future, is that we will then be able to then provide a consistent and dynamically updated view of all of this through the transient database, and also through more improved interfaces to the GCN. And so another area that's of course of particular interest when we are dealing outside of our very specific GRB framework is the fact that lots of people, there are events, and lots of different people see the events. In fact, particularly the most interesting events are seen by lots of different people, but they all have different names. And you want to be able to both make sure that you understand that you are all talking to the same event. You want to be able to have interfaces that users can go into, and given any of these names, it will find both. It will be able to uniquely identify the event, and it will also be able to find all of the data, regardless of which name it happened to use. So I don't know. And again, we have systems for targets, for fixed targets called NED and SIMBAD are the primary name resolvers, which given you give them a name and they give you both all the other names and a location. we're envisaging a similar thing for a name server, which will give you will give it one of the potentially these many names. It will give you a standard name that you can use, and it will also then tell you some basic information about that event. So, and so now onto the database, and this is I'm just talking about a very simple system that we have developed so far, and that we are trying, and this is intended to be the beginning of our multi-mission transient database. But what it really is to start with is it's essentially a way of getting in and being able to treat the all the bursts, all of the information we have from the GCN over the past many years as a database that people can view and that can be updated dynamically in time. So we want, and so the idea here is to say, okay, what do we have so that we can tie all these things together? And it's nothing particularly special. We have what seems to be a large number of tables, but in fact, we're talking about a few different kinds of things, so it's not too surprising. I'll talk about these in various groups. I'm over here in this corner. This is sort of the core thing. This is the astronomical event. This is something that's actually happening. So we have an event table. And we'll talk a little bit after I talk about what these things are. I'll talk about how we populate these various tables. So this is the thing that people are really interested in. This is the gamma ray, a given gamma ray burst, a given gravitational wave event, a given neutrino detection, whatever those items might be. The GCN produces two basic products today. It produces circulars, in which we have are split into two tables. We have metadata about the circular, basically when it was created, what the object was associated with was. That's in the circular. And then there's a second table, which is basically just text of the circular. So it's circular body. These are generally free form in much text that users can go and essentially anything that an observer wishes to say about an event can be put into here. So that users can, so if you want to follow the what happened after a given event was noticed, you may see a sequence of circulars over a period of several hours or days. But this will be digested, and in some sense, these are the discussions of the event. More a sort of more raw level of data are the GCN events, and GCN notices. And the notices, we have a number of tables that talk about the notices. We have a notices table, which is the notice metadata, and this is just basically it's just a table that will tie things together, and it makes sure that we don't put the same notice in multiple times, which does occasionally notices do get sent twice for reasons that I'm not entirely clear of. And then the notices are broken down to essentially three different views of that notice. One notice is the notices consist of basically keyword value pairs, and what we have in here in the details table is every keyword value pair for each notice. So you can go, and if you wish to say you're looking for a trigger time and you know exactly what you're looking for, you can go and look in the details table for that. There is a raw notices table, which is roughly the equivalent of the circular body field for the circulars. This is just the notice as it was sent out originally, and we give it, and we we use that if we just want to display the raw notice. And last, and obviously not least by giving this name, is what I'm calling the master table, and that's really a grandiose title. It should really be called something like the time/events table or something. And what this is a table where from each notice we've extracted every time and every position that is described in that notice. And some notices may have, something started at such and such a time and ended at such and such a time, and then we did something else at a third time. And there may be one or two positions, here's where the telescope was pointing, and here is where the target was, and so there may be two positions. And so if there are 3 times and 2 positions in a given notice, this will actually create, this master table will have all possible combinations of that. And the idea is that if you're doing a time position search and you don't have any, and you simply want it to be as broad as possible, you can use this master table and you can do a time position search, and you will find any event any notice that could match any, could match that constraint based upon any of the possible times or positions that are included in there. And these two little metadata tables at the bottom here are what are used to the metadata, so it knows what keys and what time are to be used to populate times and positions. We also have more metadata over on this side. I'm hoping you guys can see my mouse, but I'm using it sort of to guide the view. And these are basically information about the observatories that are sending in, on which these circulars or notices are based. There's a bit of redundancy here. Missions and observatories should actually be combined at some point. It's just that originally there was a set of tables here, and there was a set of tables in these two systems. So we're combining these systems. These two tables have not quite been combined, but basically they're saying the same thing. Who is it that sent out the notice or circular, and what metadata do we have about them? And the MMMW table is basically trying to tell for each observatory what is this what is the messenger? Are we talking about gamma rays? Are we talking about gravitational waves? Are we talking about neutrinos? And so it's just providing the metadata associated. It's a sort of sub table for some of the observatory metadata. So that's what we have over here. The only thing I think that table I have not explicitly talked about here is the event notice table, and the event notice table is simply a joining table which says that for each event, what notices are associated with that event. The tie between the circular and the event is done because there's a field in the circular. Basically, every circular, as part of its metadata, says what event it is associated with, except for the few circulars that are not actually associated with events. There are occasional ones that are simply sort of housekeeping circulars, but in general, notice there are many notices, and not all notices are associated with events. So we need a separate table that actually couples these two together. So how does all this work? Basically, we have and some of this exists today, and some of it is still under development. We are taking in, and this part is all working. We are in real time as the GCN sends out notices. We are retrieving those notices. We parse them. We create all of these tables. We create the master table. So it takes about a second or two after the notice is received before we're done ingesting this part. We then have the software in place, but not yet released, to ingest the circulars and create the circular body tables. These are and so we have software which can run offline, which can populate these tables, and also these two tables up here. The person who wrote the software here is one has left, and so we're in the process of integrating the software. We also transitioned from using I can't remember what the database was originally, but all of this now is in a Postgres database that we are querying. So, oops, sorry. So I just going over what's here. Again, I don't think there's anything. There are of course the metadata tables are populated manually. We actually and so that as new observatories come online, we need to do something to make sure that we have the appropriate metadata for that observatory. So there is a little bit of overhead there. All right. Then going sort of what are the key issues that are going on? There is no table there. You may see that associates with the name resolution. We envisage that there will be a new table that will be created. When I talk about things being under development, all of those tables exist and are populated today. What does not necessarily exist today is we have not either put in the process for doing these things automatically, or really for properly coupling the event notices table with the events. But all those tables exist. We expect that we're going to have at least 1 or 2 more tables to handle the name resolution. Basically, we'll have an alias table which says, here for this name there is this, for this event there are these aliases. And so when a user comes in and requests and makes a query based upon some name, we'll look at in the aliases table and see, here's the standard name we should use to query the database for this one, and we'll go off. That has to handle, there are a few special cases there, obviously. What happens when there are initially 2 events and we decide that they're the same event? We have to, what is the process there? Or alternatively, which presumably will happen someday, is we think 2 events are the same initially, but in fact, it turns out that these were 2, the rare case where two things happened both in the same, nearby, both in time and position. There's an issue I think that we need to think about is we talk about events and objects. So I think there are events. You have an event and you detect a gamma ray burst and you associate it with some object. It's great, but now you have further detections of that object. You're not really detecting the event. You're talking about the object where the event occurred. Right now, our associations are all sort of one-to-one. We say that these things are together. We don't, but we clearly need a more sophisticated approach where we talk about probabilistic associations. We would like ultimately to be able to handle data from non-GCN sources. And I think I mentioned that, in fact, the missions and observatory tables are really doing the same thing, just need to be merged together. There are some other practical issues when our system starts. Well, this is not in the database side, but this is really a very straightforward, and we haven't done anything particularly clever here. It's just a basic rendering of what the basic objects are in our system. This is, I unfortunately cannot show this to you because to use Zoom I have to leave Goddard, and so I am working from my home computer here. But this is essentially what it looks like. It's a very simple interface. You can go here. You can say, here are the kinds of objects I'm interested in. Here are the wavelengths I'm interested in. You can click on these to either turn them on or turn them off. You can do a search based upon a particular event. You can look for a particular circular. You can look for a time range for in which the event may have occurred. Then you can go and you can pick one or more of these events and decide you're interested in them. If you pick one of up here you have three different things that you can view. You can view the list of events, you can list of circulars, a list of notices. If you click on one of these, then only the circulars associated with that particular event, and ultimately only the notices associated with that event will show up. And then you can click on one of those circulars and you can see it. Of course, can you see what the you can see what the observatory was that associated with the circular, and here's the this is the MWMM table we saw earlier, the multi-wavelength, multi-messenger. What kind of data was associated with it. And then you can you can click. So I say you can click on this, and then the circular will pop up. It's basically a small document that you can go and you can read and you can see what's going on. Obviously, you can get some of the data about the basic data about the observer has been extracted and put into the events table. And similarly, and this is not working today in the sense that we have not tied it so that the selections are appropriately constrained. You can click on, but you can in fact click on a notice number, and you will see that entire notice pop up. And so we will, and so that's the interface that we are envisaging. So basically, it's a viewer of the simple viewer that allows you to see all of the gamma ray, all of the GCN event data going back. I think I think for some of these data sources for decades. So I think that is it. So.
Hey. Thanks very much, Tom. I'm a database person, so I could fill up the whole of the next 30 minutes with questions. So to spare everybody that, I'll ask if anybody would like to raise their hand with in the Zoom client there with a question. Okay, well, I'll start off with a question. I'm surprised that Andy Howell has not jumped in and asked a question. Oh, Don Petrovic has a question.
Are all data open, or do you ever deal with proprietary data?
At the moment, all the data that we are providing is open, but I believe that we are contemplating what will happen with if there is proprietary data. I guess I'm from the HESARC, where we have what we do is all our data is open, but some of it is encrypted. And it's possible we could have a similar approach here where you could see, but I don't think we have entirely addressed that question. Maybe Judy, would you have a better sense of what we're doing with proprietary data?
I mean, at this point, Scott, correct me, I think Scott's here, correct me if I'm wrong, but I think the only proprietary data is like some test notices for some instrument teams. It's not really proprietary, it's just not necessarily useful. And the only real significant proprietary streams GCN's ever handled was when the LIGO Virgo alerts were private, and those are not anymore. So we're not worrying about that, and all that is incorporated into the system. But Scott might have more to add.
Okay, go ahead.
Okay, now am I connected?
Yes.
I will just add to what Judy said, that for a while, some years back, Amman had private notices. So that's part A. Part B is that Swift and Fairman, I won't say they're private, they're more like operational notices that come down from each mission respectively, and they get sent to Swift members only or Fermi team members only. They're just called an internal class as opposed to a private class. But there's nothing in those messages, the internal ones, that would really change the transient person's conclusion. They're just more of backup and housekeeping information and things like that. And lastly, as Judy said, the LIGO Virgo ones are no longer private, and the Amman ones that they've stopped. The GCN still has the ability to have a subclass of notices that are private and get chosen in the filtering functions like they used to.
Yeah.
That's the end of my comments.
And I think that if we had, if we had to deal with this, we would, it's actually a non-trivial element to put in both authorization and authentication and all that kind of stuff. So we have not dealt with it. It wouldn't be particularly difficult to, add an appropriate fields to make particular notices or circulars private, but we have not. We don't have to. I'm glad we don't have to worry about it right now.
So on the general subject of, well, not really privacy, but restriction, are you able to assume that everything that comes through is not itar controlled? This is perhaps more a matter of curiosity.
I guess we are, we get our data through the standard interfaces that, we subscribe to the GCN just like any other user would in terms of our data inputs. And so I'm guessing that the GCN, this again goes back to Scott. Scott would not be allowed to send it out like in the sort of public way that he does if it was not itar controlled. So basically, we're depending upon it at that level.
Okay, I see Scott has no microphone, by the look of it. Okay, yeah, no, and this is actually, yeah, go ahead.
Well, the answer is, geez, I hope not. I would have been thrown in the slammer decades ago, but you know, each mission is doing this on purpose to get their information widely used as much as possible. I gotta think or gotta hope that they're doing their own checking about what you just asked about there. I mean, Swift announced it, you know, even from the proposal for it, that we would be doing all this stuff. So there was a long time to get used to it, or if somebody didn't like it, they, you know, some official type person didn't like it, said it was potentially infringing upon the boundaries of such things. And I've never gotten anything like that. So I think the answer in practice to your question is no. Nothing has ever been itar or otherwise, what is it, EAR nowadays, I guess it is, but that's never happened.
Okay, cool. Yeah, because I mean, it's potentially something that we would also have to worry about if we became, in some sense, an archiver and then releaser of information. So I just wanted to know what the situation was. Does anyone else have any more questions? Because I do have more than one question about sort of roadmap and so on, but I don't want to dominate this. Does anyone else like to ask anything? Don has another question.
When I think about one of the benefits of the hub subsystem that this project is constructed, I tend to think of it as kind of a flat place to integrate all kinds of things. And therefore I was very interested in the slide called Time-domain Astronomy Coordination TACH that showed GCN in the middle of a kind of star with only a little bit of things hidden behind AMON. Do you think this picture is obviously GCN centric, but what do you think of the integration complexities of all these entities, and how does one get a sufficiently reliable system out of that?
Well, I think that's, you know, that's sort of above my pay grade. So, but in terms of the database elements of that, a lot of that has already been taken care of by the protocols that have been set up for sending data to the GCN. So if you look at these things, I mean, AMON, Swift, Fermi, LIGO, I believe TESS are already sending data to the GCN. So I think there is a real issue about the volumes associated with the ZTF and LSST that, you know, we talk about, you know, our systems are scaled for events that occur, you know, on time scales of minutes, whereas, you know, we're going to have tens of events every second coming from those guys. But I think that's a sort of a scaling issue that we will need to address. And I think our belief is that although those are very high density events, and we are not trying to solve transient astronomy for all of the issues in transient astronomy. We are particularly, I think, interested in the high energy aspect events, and so that most of the ZTF, you know, we're not interested in the asteroid notifications and variable star events that ZTF and LSST will be creating, which are, of course, the vast majority of those things. I think that in terms of the actual scale of this, in terms of the number of, in terms of volume, I don't think there is an issue. There is the question about metadata complexity. Can you build descriptions that are appropriate for the you know, and work throughout the community? There, I think there is an issue. This is an issue that would ideally have been solved by the virtual observatory people, and they did, of course, write virtual VO event, but the VO event standard has not really proven to be popular, and I think also is not scalable to some users. And I think this is a real, you know, it's a real concern. I think that you talk. I think, I guess the other area is, you know, in terms of the way the organizations talk to each other, everybody, it's sort of, it's just like in the universe, everybody sees themselves as being at the center of the universe. And so we see all the things that flow into us and the things that we are flowing out. The fact that there are potentially other, flows, I think is not, is not something that we, I don't want to say we're not concerned with it, because that suggests that we're, that we're above it. It's just, I think that we see ourselves as a important element of this interchange of data, and we expect that there will be other important elements. And as this system grows, and I think that's why we are presumably talking, is because you're also doing many of these same kinds of things. We need to make sure that those things work, that those elements work together. But until and unless those systems emerge, it's sort of hard to talk about things in the abstract. But I think this is really more a thing that Judy should be talking to, and not me. So maybe Judy wants to say something.
No, I think you answered that well. But yeah, this is not the, I know maybe for some of you, this is the first time you're hearing about TACH, but this is not the first time TACH and SCIMMA have had discussions. And so we are trying to figure out how, our systems can work together and, be most functional for the community. And this is, the third or fourth time, we're having this discussion.
Right, so I'm just, I decided I could finally share the slide as well, so we're being talked about.
Yeah, this was a figure from actually our original proposal describing how the new elements of that we were proposing fit in with the existing GCN system, and ways in which the community might interact with our system. So this was not meant to exclude what SCIMMA might be doing, but this was just independent of that.
Okay. Thanks for that. I see on the subject of how SCIMMA and TACH may work together, perhaps Andy may have a question.
Yeah, so right now we're making our own GCN database, but is it worth combining forces somehow? Should we use the same database, or maybe share the schema for our databases? What do you think about that?
I certainly it doesn't hurt for us to send the information to one another. It's our databases in particular are designed to support the interface that we are building, and I assume your database is in fact designed to support the interfaces you're building. And there are, I think, some similarities and some differences between those. Again, I was not here at the presentation when SCIMMA gave its talk, so I'm not quite sure I know what the scope of that is. But I certainly don't think it would hurt to exchange information. I don't feel this is a very complex. What we're doing is very complex, mostly. So I don't have a strong feeling that there's look at all these clever things. Maybe that means that we should be sharing what you have, because maybe you have done clever things and we completely haven't thought of. But these seem to be very straightforward tables that describe, information and sort of have, appropriate and straightforward links between them. So I just don't, I don't think, again, it would be silly for us not to at least share this, but I'm not sure there's a vast amount of labor that we would save by copying one another. Although maybe, again, I have no sense of what clever systems that you may have defined.
Yeah, we're still in the earlier phases, so that we don't have a huge amount of work put into it. But yeah, I think it would be great to at least keep in touch and see what each other are doing, and if there are ways we could save effort, we can. But yeah, often we will each have our own needs for driving our own certain interfaces and things like that. But I definitely want to make sure we are in communication so that we don't duplicate too much labor if we don't have to.
And the one area I think that would matter is in sort of simple things like, let's use the same words for, let's use X-ray with a dash always, as opposed to one of us using X-ray with a dash and one with a space, so that users know what to type, as we make, presumably we're going to have programmatic interfaces to this, as well as, human interfaces, and we want to make sure that our systems are consistent. And tiny little changes like that can make enormous difference, I think, to the ease of users using both of our systems, while having essentially no impact on us, except that we actually have to think about it in advance.
Yes, absolutely. And I don't know if you covered this or not, but do you plan to make anything in your database available via API, or is it just through the GUI?
All of this should be available through a public API, but not till after we, not now, but in a few weeks, hopefully.
Oh, cool. So Andy actually asked two questions I was going to ask. So is it you that we should write to get a copy of this database schema?
Sure. Yes.
Okay, great. Sorry, Andy, I butted in there. Do you have any more questions? I see Rich has a question.
No, that was good.
Cool. No, thanks. Rich Wolski has his hand up.
Hi, thank you. Maybe you could talk a little bit about the software and maintenance lifecycle for this system, and what your sort of scalability concerns may or may not be, your reliability SLA, how available do you expect this system to be? Are you doing sharding? Do you have a deployment mechanism for sharded Postgres? These kinds of questions.
Well, the tables we're looking at are quite, are in sort of modern parlance very small. I mean, we're looking at hundreds of thousands of rows in our biggest tables. So that things like shard, I mean, I tend to think of that as being useful once you start getting over the 10 to 100 million row limits. We don't have that kind of thing, and we don't see that necessarily any time in the 4 to 5 year future. With I am not aware of any such needs. So I don't, the areas where we are looking at performance and enhancement is in sort of the user interface side of things, where right now, just a very specific example, we're downloading the entire tables when we start the systems up, whereas of course we should be downloading only things where we are that are actually being displayed and updating that. So our performance concerns are on the user interface side of things, not on the database query elements.
Okay, so maybe reliability SLAs. Do you, if the database goes down, how angry do people get?
Well, I guess this is we don't have a system up yet, and our experience has been for the database systems that we run for the virtual observatory, the ESAR, is we have a goal of 99% uptime, and we have basically maintained that successfully for the past 2 years. When things go down, people we do get complaints. I think this is something we have not dealt with a lot in this context, is that because of the time critical nature of some of the things that happen, if a database goes down at the wrong time, it's going to be a more serious issue than it would have been for for our standard TSARC results, where if a database goes down, people can come back tomorrow, and there's no, basically they've not lost anything. Whereas here, if the database goes down during, as a gravitational wave event is happening, we've got a crisis. And I don't know that we have thought that through as carefully as we will need to. I think the GCN has, the GCN itself has sort of internally mirrored capabilities to address this. And as we go towards operational deployment, we will be looking at something in that where we would actually have a replicated database and I think multiple sites hosting it simultaneously. So
yeah. So that may be a point of collaboration as well, because I think this group has put some thinking into the automation required to do that kind of thing for the software that it's been producing. So, not necessarily for scale reasons, but for reliability reasons, it's possible to deploy the software such that the database that's internal to it is replicated. And then that, comes with a whole bunch of scripting that's tied into the authentication mechanism, as Don will tell you, to make it secure. There's just a lot of maintenance and lifecycle work, I think, that's been put in to the SCIMMA stuff that it might be useful to collaborate on.
Yeah, I think that's certainly something. It sounds like you are well ahead of us on. Although again, I know that Scott has done some work on that in terms of the GCN. So.
Yeah, I definitely think Rich is right. We could work together on making sure that things are robust. And Andy, your hand, is it up again, or is it still up from before?
Oh, sorry, I forgot to put it down.
Okay, no worries. I have one question. Everyone's been doing a splendid job of anticipating the questions I was going to ask, so you don't have to listen to me banging on all the time. But you're talking about associations between events, from different sources. How are those being made? Are they? Do you have a platform to do that yourselves, or are you relying on, say, brokers and so on to give that information to you?
That's one of the three prongs of this effort, and one I have very little personal insight into, but Judy is, I think, specifically leading. But there is a whole framework to actually, both do this earlier in the process, so that as it seems in the GCN, as the information starts flowing in, and we're getting it from our data providers, that there will be a whole software framework that will do appropriate probabilistic comparisons of these two things, and there's questions of whether we should be using appropriate, all sky maps with the probability of the event is in a given location, and then joining those in a variety of clever and intelligent ways. But maybe Judy would be more appropriate to answer that.
Sure. So this is actually an effort that Eric Burns has been working on, though I don't think he's here today, who's part of our team. So yeah, this is mostly related to, GRB prompt emission, where there's a distinct, time, a distinct, time when the GRB goes off. Different instruments can trigger slightly different time periods. Gravitational waves we would also expect to be within, a very short window of that. And so there's been work that's actually come out of the joint working group between the Fermi Gamma Ray Burst Monitor and LIGO in terms of some of the statistical framework for association. And we're adopting that same framework to do this event association code within this system. Now, associating, a kilonova that was, maybe due to the same astrophysical event, but was detected hours later, or some sort of other optical transient. That's a much bigger task and a much more challenging, both spatial and temporal association. But at this point, we've really just been looking for things that are discrete, short time duration transients that we can do a temporal and co-spatial when possible association.
Okay, I see. And just before I go to, because Patrick has a question, and is it the case then that when that association's been made and some probability has been associated with it, that is then, if I remember from the diagram, is that association then sent as a GCN as well? So that everyone who subscribes.
The GCN already does that, I think, for when.
Okay.
It actually has some facility for doing that already, and we would assume that would be extended in some.
There are comments that get added to the bottom of GCN notices when two events are seen by two different instruments within a certain time window. This is a little bit more sophisticated than that, and we certainly get the association with our database, but I guess we haven't really thought through if we would create a separate GCN notice type to announce these associations, but it's an interesting idea.
Okay. Thanks for your answers there. And Patrick, sorry?
Scott has an answer.
Can I make a comment here?
Sure, go ahead.
Can I have the comment? Can you hear me?
Barely.
Oh, barely? Well, I'll yell here. The GCN has a notice type which is nothing but coincidences. In real time, it just keeps absorbing, so to speak, everything that comes in, and it checks a ring buffer that's about 10 days long worth. And if there's any notices that are within plus or minus 100 seconds of each other, or I think it's 20 or 25, no, that's not true. Well, there's a temporal coincidence is applied and a spatial coincidence is applied. They're independent. And obviously, some, hopefully, detections will have both time. As Judy mentioned, I put comments at the bottom of outgoing notices for some of them, but it wasn't until about 5 years ago that I created this specifically coincidence-only notice type that does temporal coincidence, spatial coincidences, and the combinations of both. And those are all done automatically and sent out. It takes a very small fraction of a second to do those comparisons.
Okay, cool. Thanks. And we did hear all of that, actually. So thank you for that, Scott. But Patrick has a question. I think this might be more or less the last question.
I wanted to go back to the API for the database and the status of it, and related questions of authorization or authentication to use those API calls. Have you got a designed API for the database yet, or is that in early stages of development? And again, how are you thinking about dealing with the issue of identity within that context?
I think again we're hoping, at least in the initial release, that there will be no information that is not acceptable, queryable by any user. This is sort of the standard with the HESARC, where any user can make any query, do any query of our existing resources. So we anticipate I'm anticipating we have a system for querying the HESARC database, which we call Examine. I'm expecting that we would be using the same kind of interface, and possibly even much of the same code could ever use to do this. And that basically allows users to send either keyword value elements, where you basically you specify the position equals X, radius equals Y, time between A and B kind of queries, or you can do arbitrary SQL, and this causes us all sorts of grief with NASA security managers, because they say, why are you allowing people to send SQL to your databases? But what we have chosen to do is before we run any query on the system, we make sure that we parse the SQL completely, and then we ensure that it is, that it's not doing things it's not supposed to, like, obviously doing updates or querying system tables. So it is, it's our hope that basically that same kind of framework, and possibly the same framework directly, can be used for providing support for this database as well.
And Tom, it's a long time since I've used HESARC for anything directly, so I've forgotten a few things. So, for example, how would you plan to handle throttling of queries from specific places or people?
We have not, in generally, done any throttling of users, and every year or two we regret that, because we have to actually explicitly shut down one user who comes in, and this has and so I keep on talking to our systems people about, should we do something where a given user should only be allowed 60 queries a minute or something, but the answer but we have not, we have basically left it open. And every once in a while it causes us grief, but mostly we are okay. Now that may be something we need to rethink about again in the context of this database, because it will become highly, the demand for it is going to be very much more time dependent than it would than for the HESARC system for and it's more critical that we allow, that we ensure that all users get a fair allocation. After that big gravitational wave event occurs, we can't have one user hogging all the resources. But we have not found that to be a problem, except on a sort of once a year kind of thing. And we actually have seen that with the other observatory, the other NASA observatory archives have adopted similar non-policies, in the sense they let users come in and have had similar level of problems where we have a meeting once a month, and roughly once a year, each institution talks about how they've had some user who caused them grief, but it has not caused us to put in explicit limits to users, partially because the technology keeps on getting better. So we find that if we try, or we haven't in the past tried to put on limits and found that within a year or two they were absurdly restrictive.
And just out of curiosity, the identification of user in that context, is that just via IP, or is it?
We have users there would be in these cases by IP. We do have sort of user sessions where a single user can preserve information for future queries, but that's not been no such user has ever been implicated as a problem in terms of denial of service issues.
Got it. Nice. Yeah. So I definitely, like Andy was saying earlier, it'd be great if we could take a look at what you've done in terms of database design, and then thinking about ways in which we could really deepen the collaboration, either by partnering on some things or else or sharing some technologies. Anyway, good. Thank you.
Okay.
Great. And thanks very much for that, Patrick. And I'd like to thank Tom and Judy and Scott, Tom, for giving this talk, which was very interesting. And I hope that moving forward, we should be able to get some real synergies together. And I'll just advertise that we're having another public telecon next week, where we'll be hearing from the other sort of multi-messenger astrophysics center that was, project that was funded through the Harnessing the Data Revolution program. And we'll be hearing from some combination of Phil Harris, Elihu Huerta, and Eric Katsanidis, I believe. And so please tune back in again next week, and we'll be sending out an announcement presently. But thanks again, everyone.